All right, today's date is Wednesday, May 5th, 5/5, Cinco de Mayo, 2021. Final review for exam number 2, Wednesday. All right, so for problem number 3, we have that graph. It tells you there's semicircle and line segments, which is awesome. The technical definition for semicircle, again, is exactly half of a circle, so we know that's exactly half. And we know that a g of x function is this accumulation integral starting at -3, which will throw us for a wild ride depending on what we're doing here. So find g of 0. Since we're talking about g, this definition of the accumulation integral, just plug in 0. We can say g of 0 is equal to the integral between -3 and 0. I'm just plugging in 0 of f of t dt. And I'm always super formal whenever it's a free response question. I do always write f of t dt instead of just writing f, although I don't think you'd lose any points for not being formal. So we do that. So from -3 to 0 is the correct direction, luckily, so we're not thinking backwards. It goes from a negative to a positive. So -3 to 0, we're looking at these bounds right here. Let me section them off. That line is a little bit off. -3 to 0, so all of this area. So I need to somehow draw a line here to kind of divide up my areas nicely. I have a rectangle and a triangle. This rectangle has an area of 3. This triangle is the same rectangle, but half of it, so 1.5. Or you can think of it as 3 halves if you prefer fractions, which means the entire area here is 4.5. 4.5. So that's g of 0. What about g prime of 0? G prime of x. Let's deal with that first. What happens when I take the derivative? When I take the derivative of an accumulation integral, this x gets plugged into whatever the input value is, t, and then let's go ahead and write that down, and I get rid of the integral. So I have f of x, and then you always multiply this by the derivative of whatever you're plugging in, so times 1. It's kind of silly to write that, so I'm not going to write that. So it's just f of x, which means height at any point, which means g prime of 0 is going to be f of 0, the height at 0, the y-coordinate at 0, and the y-coordinate at this x-coordinate 0 is 1. So this is going to be equal to 1. All right, no questions? On to part B. Find all values x in the open interval from -5 to 4, where we're at a relative maximum. All right, so it's always helpful to have the definition of a relative maximum. So f relative maximum. What is the definition, Andrea? It's from a positive into a negative. Exactly, and we know what f prime is. F prime is, or sorry, we're talking about g prime. So I should come back here and change these f's to g's, shouldn't I? We're so used to always dealing with f, so it's a g relative maximum is where g prime goes from a positive to a negative, and we know g prime up here, g prime is f. So really what I'm saying here, if I change this is saying where does f go from a positive into a negative, and I can put up here in quotes, we're talking about height. On a graph of f, what is f? Height. So I'm looking for all heights where I go from a positive to a negative. This height goes from a negative to a positive, so wrong direction. This height goes from a positive to a positive. And finally, just at this x-coordinate 3, we have a height that goes from a positive to a negative, so only at x equals 3. So our final answer here will be x equals 3. Why? Because of all of this stuff. Because g prime was positive into g prime be negative. Perfect. All right, and part C, find the absolute minimum. I'm thinking table here. Anything that has to deal with absolutes are usually about the Sith and tables. So let's go ahead and make our table, give some room for our conclusion at the end. So I'm going to go right about there, right about there, right about there. I think that's a good amount of room. And we need some values of t, right? T not x, yeah. So we need t values. We always want to do the ends, the start and the end. So we definitely need a -5. We definitely need a 4. We'll do a start plus change, and that should be equal to our end value. Do we have any start value? No, it doesn't tell us anything about any start value. Sometimes we have to be careful. There's like maybe like a 2x that's added to the accumulation integral, but that's not the case. Okay, so the next thing that's on our agenda is find any critical values. What would go right here? And then the answer is all CVs go in this middle spot. So the definition of a CV in terms of a G is what is the definition of GCV instead of FCV? Or? Exactly, yeah, 0 or D and E. So really I'm talking about f of x when I'm talking about G prime. So where does f equal 0 or D and E? F is equal to 0 here, here, and here. But there's only one of those that makes sense in doing, because we're looking for a relative minimum now, and it doesn't make sense to or an absolute minimum, sorry. It doesn't make sense to log a critical value that isn't a relative maximum. This one up here, x equals 3, was a relative maximum, and that doesn't make a lot of sense. So let's only do the relative minimum. I'm only going to do -4 here. So only this one, -4. Save us some work. Oops, -4. Oh, but we have to be careful here, don't we? Because relative minimum, maybe I should include all of them to see what's happening, because when you have this bound that starts at -3, weird things tend to happen. So just to be on the safe side, and this is kind of how I want to train all of us as well, to be on the safe side, if we don't know what's going to happen, just include all critical values. This one just makes no sense, because you're always going to be going positive from -3. But I'm thinking more logically, I want to avoid work. If you want to be on the safe side, yes, we can do that, but we're looking for an absolute minimum. So if I think about what's happening here, my accumulation integral definitely starts here at -3. No matter what happens as I go to the right, I'm going to be accumulating a bunch of positive area. Even though I have this tiny little slice of negative area here, that's just going to cancel out with that tiny slice. There's no way for me to have a minimum value anywhere over here on the right. So I am going to go ahead and exclude this CV over here and this CV. I'm only going to include that -4. I'm okay doing that. Okay, so our start, we don't have a start, so 0. And then plus our change. This is going to be the integral from -3 to -5. Oh, that's backwards. So let me go ahead and right now switch it and then make this a negative. So this is now going to be -5 to -3 and switch this out to a negative. In fact, I'm just going to go ahead and get rid of that plus sign so it doesn't confuse us. This is now going to be, oh, I didn't mean to make it thicker. Just a negative. Oh, I can't. Computer, please. A negative. And then this one is going to be, again, the same thing where I'm going to subtract a bound because my bounds are going to be reversed. It would originally be from -3 to -4, but those are backwards. So I made it into a negative, and then have the bounds correct from -4 to -3. And then finally, my last bound is going to be, I know I'm squishing everything in here, my last bound is going to be between -3 and 4, which doesn't make sense to do, so I'm not even going to calculate it. Because we know that everything that's out here to the right is going to be a giant amount of positive area. Only two that I'm concerned about are these two. So in here, I'm still going to have an f of x dx and an f of x dx, just by the definition of what the accumulation integral is, just rewriting this essentially. Okay, so from -5 to -3. So I'm starting at -5 and I'm going to -3. Notice that this triangle right here and this triangle right here are congruent, therefore their areas cancel each other out, and therefore this accumulation right here is 0, so our end value is 0, which is still a good minimum value, because remember that a ton of this stuff is going to be positive area, so it's bigger than, or smaller than positive. This next one is probably going to be the answer. If I just look at the integral from -4 to 3, -4 starts right here to -3, means all of this positive area, this would normally be a rectangle that has a height of 3. This width right here is 1. 1 times 3 is 3, but half of that, so 1.5. Again, this triangle tends to be, or happens to be the same congruent triangle that was up here. So we know that that was 0 minus that positive area of 1.5, giving us our minimum value of -1.5. And if you want to have a justification on why we got rid of that, it's a big positive value. Definitely can't be a minimum. So let's write our conclusion. Always have a conclusion. I try to give myself room under here. The absolute minimum, min, I'll say absolute min is negative 1.5 at x, or actually t equals negative 4. Yeah, so the tricky thing for this question, just to remember, the bounds, whenever the bounds are not in the correct order, make sure that you're flipping the sign, or at least thinking backwards. Backwards being, hey, positive area now is negative area because I'm going backwards to the left instead of the right. Questions up at this point, Andrea? No? All right. Part D, find all values of x in the open interval at which the graph of g has a point of inflection. And so we're just going to go ahead and do g inflection point. Definition, Andrea, is g double prime, a sign change. All right, so what is g double prime? Well, we know g prime is equal to f. Therefore, g double prime must be f prime. F prime on a graph of f is what, Andrea? Height, slope, concavity? Slope. So we're looking for, over here, slope. Slope, sign change. And let's pay careful attention. So we're positive, 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 and oh, we switched to a negative right here. So let me, do I have a highlighter tool? I don't. Okay, so we have a slope sign change once, keep going, negative, negative. It's even more negative. It is a sharp corner, but we're still fine. It's still negative, negative, negative. Oop, positive, positive. We switched signs right here. It was a negative slope up to a positive slope, and then, oh, again, back to a negative slope. We switched signs a total of 1, 2, 3 times at negative 3, 1, and 2. X equals negative 3, 1, and 2. Why? Because g double prime is sign change. Let me zoom out. Any questions on that free response question number 3? Nope. All right. Let's jump down here to multiple choice question number 14. So I see a limit as h goes to 0 and h is on the bottom, which means I'm dividing by 0. I immediately think, okay, that's not possible. I'm going to get some sort of indeterminate form. And even more so, usually when we have an h, that almost always means you're going to be doing the hotbox rule. And indeed we are. So as a reminder of hotbox, the way that we do that, everything typically in the top left, the thing that has an h being added to it, everything up there is the hotbox, which means get rid of everything else. Just focus your attention right there on the hotbox. So we know that the value of c is the thing being added to h, so the value of c is 2. And then everything that's in there is going to be crossed off. This is all going to be just an x, so our function here is e to the power of that giant x, e to the power of x. And because this is the definition of the derivative, take the derivative. F prime of x is equal to, well, doubter is e to the power of x, then multiplied by dinner. The inner is x, therefore dinner is 1, so times 1, and I don't really need to write that. Cool, and then we just need to plug in our value of c. What is f prime of c? And that is e to the power of 2, and e squared is d. All right, just memorizing our hotbox rules. Let's do number 16. By the way, we should take a look at the stats while we have some time. No, I don't want to look at you. So number 14 is right here. The average score is 60% over the years. 2 out of 3 of us got it correct. That's pretty good. Then we're jumping down here to 16, 52% on average. Only one of us got it correct this time. F prime of x is equal to the absolute value of x minus 2, which of the following could be a graph of f of x. So I'm going backwards. So it's like I was taking the antiderivative of this piece. So this is the graph of this right here is f of x is equal to the absolute value of x minus 2, which is definitely not the right answer. But it does help us to understand, okay, if this is the derivative, and I want to take the integral to go backwards, I'm really thinking about the area underneath that line as the amount that I should be increasing or decreasing. So I should be increasing a ton over here where I'm negative. I shouldn't basically be increasing at all. I kind of have this, I'll be increasing, and then I shouldn't be increasing, then I increase again. I should be looking for some form like that, where I'm increasing, then I stop, and then I start increasing again. So B doesn't match this picture of increase a ton at the negative. Actually, this is decreasing a ton, so it's kind of like backwards, right? It's decreasing a ton and then increasing. That doesn't make sense. We have positive area and positive area. We should be increasing and increasing again. Can't be B. What about C? I'm randomly not decreasing at 0. That doesn't make sense. I'm randomly not decreasing at 4. I should be increasing everywhere except for 2. So not C. Let's look at D. D is really promising. So D is increasing, and then it drops off at 2, and then starts increasing again. The only weird thing is you jump down here. I don't know why we have this this jump down here. That is disconcerting, but it's a good option if we have nothing else to do. And okay, E is basically the graph that I drew up here when I'm thinking increasing, kind of drops off, and then increasing. The correct answer is indeed E. It increases, kind of drops off, doesn't increase here because we have a height here with no area under it at 2, and then increases again. We shouldn't have any weird discontinuity happening here because there's no, I guess there is kind of a sharp corner here, which, ooh, would that make anything different? Now I'm wondering if D is the answer because we have a sharp corner. So if that is the derivative and I go backwards, so it's okay. So if I go forwards again, I have a discontinuity which would continue out whenever I take future derivatives. But if I go backwards, I shouldn't have any discontinuity because this is continuous. It's continuous. It just happens to be not differentiable. Continuous means I have to hold down my pencil and not pick it up, which means if I go backwards, I'm still continuous at that point. So I should still be continuous. Therefore, the answer is E. Let's go to number 17. The area of the region enclosed by these two graphs, again, no calculator, so you have to picture what these graphs kind of look like, which one is on the top, which one is on the bottom. And it doesn't actually matter because if we just get a negative answer, we can make it positive. It's not a free response question. We don't have to have them in the correct order. So let's just, I mean, we can quickly sketch them out if you want. So I have negative 5x, which is just, it goes through the origin down here and it has a slope of negative 5. X minus 2x squared. It does have a point on the origin because 0, 0 works. And minus 2x squared goes down really quickly. So it looks like it probably will do something like that, I would guess. I would guess that that's going to be on the top. But the whole point is, where do these two functions intersect each other? We don't even know our bounds. Essentially what we're trying to do is we're trying to do some sort of integral of one function minus the other, but we need the bounds of those as well. So for now, let me say it's going to be x minus 2x squared. According to my sketch, that would be on the top, minus this other function, negative 5x. And I need the bounds of those two. So let's set them equal to each other to figure out where they intersect each other. So this is me finding the bounds. To do that, set them equal to each other. X minus 2x squared is equal to negative 5x. I'm going to add 5x to both sides to move it over to the left-hand side, and I have 6x minus 2x squared is now equal to 0. I'm going to factor out a 2x. 2x, when that's factored out, I'm left with 3 minus x is equal to 0. And using the zero product property, 2x must be 0. That's one solution. And 3 minus x equals 0 is another solution. This gives us that x equals 0, which makes sense because that was an intersection. And x is equal to 3, which is probably right there. We can say that's 3, and that's where this intersects right there at 3. Okay, so we know our bounds are from 0 to 3, so we can start doing this. This seems like a really hard question because, like, just knowing top and bottom, you don't need to know that, but it just seems hard. I wonder what the stats are for number 17. For number 7, oh my God, look at that, 18% on average. All three of us got it wrong this year, so that is, yeah, I was right, that is a hard question. It's not as hard as this one, number 23. That one is insanely difficult. It's like off the charts difficult. I think this one is in second place. Is 18% the next lowest question? Okay, this is the second hardest multiple choice question on the test historically for my classes. So I have the bounds now. Now it's time to actually take the antiderivative. Actually, I can simplify this before I take the antiderivative. If I have one minus another, this is really double negative. This is really adding, right? So if I can simplify this before I take the antiderivative, that'll make my life easier. I have 6x minus 2x squared. Okay, now I can take the antiderivative. So this is going to be 3x squared. Again, go up a power and then divide down by 2. 6 divided by 2 is 3. Minus 2/3 x to the power of 3. Again, it goes up a power to 3 and then divide down by 3. And this is going to be evaluation bar between 0 and 3. The nice thing about our second evaluation when we plug in 0 is nothing happens. So really all I need to do is I need to plug in 3. Don't know why I'm switching colors so much, but let's go ahead and say now I'm plugging in. So it's going to be 3 times 3 quantity squared minus 2/3 3 to the power of 3. So 3, this is really 3 cubed, and 3 cubed is 27. Or you can think of this 9 times 3 is 27, so that's 27 right there. Kind of using the area down here for problem number 21. The quicker way of doing this problem is just using your rules of exponents and saying this is really 3 to the power of 2 and canceling out that 3. Or if you want to do it a slightly longer way, 3 to the power of 3 is 27, divided by 3, this whole thing is 9. 9 times that 2 is 18, so I have minus 18. 27 minus 18 is 9, and the correct answer should be 9, unless I've made a mistake. Hopefully I haven't. Whew, yeah, that was a tricky one. How do you feel about that one, Andrea? Okay. Did you think of, like, I have to do the integral of 1 minus the other?
Yeah.
Good. Yeah. So that's the main thing. And then finding the bounds is hard. So every single time that you need to find bounds and they're not given to each other, set them equal to each other. But if you have a graphing calculator, just graph it and have the calculator do the work. Perfect. Those are the two strats. All right. Number 21, how do we do? Number 21 is right here, 31%. Oh, but all three of us got it wrong. It's a good one to talk about then, right? All right, so we have this graph, area 20, 6, and 4. Really, I want to be thinking about this as a negative 6 area because it's below the x-axis. So I'm going to temporarily put a negative right there. Let's go ahead and read. This is a graph of f prime between 0 and 10, 20, 6, and 4. Good, good, good. Oh, it tells us a start condition. It tells us a start. At time is equal 0, or x equals 0, my start value, my y value is 2. I'm trying to find the maximum value of f on that interval. Okay, so essentially I'm making a table for this one because it's the absolute maximum. So here's my table. It's going to be my x values, start plus change is equal to n. I know there's kind of not enough room in here, so we'll try to squeeze it in here. Well, we want to test the end points, 0 and 10. Those are always on our table, 0 and 10. And let's put all critical values. Well, not all. Let's do just the relative extremums. It's a little bit more restrictive. Since we're looking for the absolute maximum, let's look for relative maximum first. So as a reminder, f relative maximum is what, Andrea? Positive into a negative. Exactly. And this is a graph of f prime. So f prime on a graph of f prime is height, slope, concavity, one of those? Height, exactly. So we're looking for a height that goes from a positive to a negative. And that only happens once, right there. This goes from a negative to a positive, and those are the only two CVs that we had to choose from. So I'm only going to look at this point right here and call that point, I don't know, A, for lack of a better term. And you can think about this logically as well. Like, obviously, I don't want to stop right there because I have a negative area. And obviously, I don't want to stop right here because this negative area outweighs this positive area. So at A must be the maximum value. And that's what it is. Our start value here is, it tells us it's 2 plus the change is the integral of f prime between 0 and A, I suppose. But that's being overly technical. It's just 20. The integral is just the area of that piece. So it's 20 plus 2. Which is 22. And if you want to check these other values in the table, you can, but you will find that they are definitely less. Okay. And then we're on to our own questions. Let me preview these to see what's going on. That looks like a hot box question. Number 2, oh, very similar. Remember this one, you have one more curve, one less curve if I'm going forward or backwards. If you have questions, I am here. Number 3, yeah, 2 equations, and you have to find the bounds on your own. How do you find the bounds? I already told you. You'll have to remember. And number 4, which of the following must be true? Oh, this one is super tricky. I'm going to put a star next to that one. I think that's going to be the hardest one out of the 4 that you're going to be doing on your own. Cool. Yeah, good luck.